Greetings and welcome to Infodome, where we curate facts about a wide selection of topics for you to feed your curiosity. In this series, we are travelling across the cosmos to give you facts about the solar system. Named after the Roman king of the gods, Jupiter is fitting of its name. It is easily the largest and most massive planet in the solar system. So let's get straight into the video to discover more. Jupiter was the first planet to be created shortly after the Sun's furnace ignited. It was then able to scoop up most of the material left over from the formation of the Sun. Jupiter is huge, we know this. It is so vast, all the other planets in our solar system could fit inside Jupiter, with room to spare. To put this into perspective, if Earth were the size of a grape, Jupiter would be about the size of a basketball. If Jupiter had become 80 times more massive, nuclear fusion would have occurred in its core. Had that happened, it would have become a star instead of a planet. However, Jupiter never got the mass needed to undergo fusion in its core. Despite its size, Jupiter rotates extremely quickly, about once every 10 hours, which is a very brief Jovian day. This rapid rotation is also what causes the flattening effect of the planet, which is why it has an oblate shape. It is so far out from the Sun, it takes about 12 Earth years to complete one orbit, a Jovian year. Jupiter orbits about 484 million miles, or 800 million kilometers from our Sun. It will take 6 years to travel to this gas giant from Earth. Even though Jupiter is so far away from the Sun, it is the fourth brightest object in our solar system. After the Sun, Moon, and Venus, Jupiter is the brightest and is one of the 5 planets which can be seen by naked eye from Earth. It is thought Jupiter has jostled for position for billions of years. Roughly 4.5 billion years ago, Jupiter's orbit began to change. It began to move inwards towards the Sun, affecting everything in its path, including the asteroid belt and Mars. It is thought this movement caused a newly forming planet, Ceres, to be decimated, and the asteroid belt are the remnants of this world. If Jupiter would have moved closer to the early Sun's orbit, then it is likely it would have stripped a lot of the material, much like it did to smaller planets such as Mars and Ceres. It was thanks to the formation of Saturn and its gravitational pull on Jupiter that forced the gas giant back out again, past the asteroid belt and back out to the position it holds today. Jupiter, as I have mentioned before, is a gas giant, and so lacks an Earth-like surface. When we look at Jupiter, we are merely looking at the upper layers of clouds. These clouds fall into bands stripped across the surface, parallel to the equator. The lighter colour bands are called zones, and the darker ones, belts. They appear to be stable, and they are relatively, though their shape and colour does change over time. Oddly enough, Jupiter's zones and belts circulate around the planet in opposite directions. The lighter zones are ammonia-filled clouds which are formed when the rising air cools. As the air sinks and the sunlight alters the molecules in the clouds, they shift colour to the yellow, red and darker brown belts. The Jovian clouds also cause massive turbulence. This occurs in regions between the zones and belts, where giant vortexes rage. There is one in particular that has caught the imagination and has been raging for centuries, the Great Red Spot. This is a huge hurricane with speeds around 500 kilometers per hour, several times larger than Earth. The hurricane gets its colour due to the cyanide-like molecules which absorb blue light, letting the red light pass through. If it has a solid inner core at all, it's likely only about the size of Earth. But this is something scientists just aren't sure of. They know Jupiter's atmosphere is made up of mostly hydrogen and helium in several layers, much like the Sun. There are other poisonous gases laced in the atmosphere, and the deeper into the planet you travel, the greater the pressure. This is where the gas slowly turns into a liquid as you travel down through the layers. In 1979, the Voyager mission discovered Jupiter's faint ring system. All 4 gas giants in our solar system have ring systems. In 1610, Galileo turned his attention to Jupiter and witnessed 3 smaller points of light on either side of the planet. When he looked a second time, they'd moved, and he saw a 4th point of light. He knew he was seeing objects orbiting around Jupiter. These 4 moons are known as the Galilean moons in his honour. They are Io, Europa, Ganymede, and Callisto. These moons are huge. To put this into perspective, Ganymede is larger than Mercury. This moon isn't dissimilar to the terrestrial planets either. It is believed it has a liquid iron core and a magnetic field generated by its core. That is not all. Ganymede has oceans of water under its surface, which scientists think will share these characteristics with the other moon, Callisto, the 2nd largest moon. Callisto's orbit is the furthest at almost 2 million kilometers away. Io is a very fast-moving moon, only taking a day and a half to track around the planet. This is the most exciting moon, as recently a volcano was seen to be erupting on the planet's surface. It is now known that Io is the most volcanic object in the entire solar system. These volcanoes are not due to an active iron core like Earth, but due to tidal heating from the moon's proximity to Jupiter. Europa is smaller than our moon. It looked to be a dead world. It was only when Voyager turned its attention to this unassuming moon that they noticed something very strange. They saw nothing at all. No craters, no volcanoes, just a smooth surface with cracks crisscrossing its surface. This is apparent when lava flows up on Earth, creating a new, smooth surface. But in Europa's case, the material is water. Europa has an entire ocean under its thick, icy crust, and as the water wells up through the cracks, it freezes, creating a new virgin layer of ice. There is thought to be more water on Europa than all the oceans on Earth combined. The cracks on the surface are darker in colour. This discoloration is thought to be due to the salt in the water and other organic compounds, carbon-based compounds, the building blocks of life. We just don't know if there is life on Europa yet. The other moons are known as the outer moons. These are much smaller and further away from Jupiter. They also have irregular elliptical orbits, and many are thought to be asteroids captured by the planet's vast gravitational pull. Jupiter is a great comet catcher. It probably had a huge influence on our history. At 318 times the mass of Earth, you can imagine that any passing asteroid or comet going near Jupiter has a big chance of being caught or diverted. Perhaps Jupiter was partly to blame for the great bombardment of small bodies that peppered our young solar system early in its history, causing scars that you can see on the moon today. It is thought without Jupiter, our planet may have been hit with several extinction-level comets. Without Jupiter, we might not be here today. So when you next look up at the night sky, turn your gaze to Jupiter. It is much more than a twinkling light in the night sky. It shaped our solar system, the creator and destroyer of worlds. Thank you for watching this episode of our Solar System series. Next time, we will visit one of the most beautiful planets in our solar system, Saturn.